Hello friends, and welcome to another video. So this is the third video in this series on the design of my power amp. So if you haven't seen part 1 and 2, they're there. So there's the introduction, and then we talked about the schematic of the power amp itself. And today we're going to look at the power supply for both the driver and the power output stage. They're the same. Of course, they use different voltages, and what I'm using is a pass tube circuitry where the voltage and the current to the tubes get controlled by a circuit. And I'm using a standard design that I found online. You can even buy it. However, I think it needs specific application where it works well, and parts where it wouldn't work well. And I've also used it in a specific way which makes this thing work. And so it avoids a little bit of use of very heavy chokes or inductors in your circuit. I still use inductors, however they have a bit lighter requirements, so they're easier to work with. And so I think when applied well, this circuitry works really well. So what we'll do in this video, I'll use it how I've applied them, and then we'll get into the positives, we get into the limitations where I wouldn't use it, and then we'll go over the details of this circuitry. Now, first thing to understand, and just let me have a look if you can see everything. Yes, you can. So if you have a look at this schematic, so this is the circuitry, and I've got it on a PCB. We've got the transformer over here, and then this is the part that you actually saw. You could see this connected, but this is actually, I have considered the LC stage that I use after the voltage regulation. This is part, you have seen this already in my in video number 2, because this was part of the power amp design itself. And I see this part as the power amp design itself, because I want a current source really close to either the output transformer or the interstage, as close to the tube as possible. So I've got current delivery at the point. So I don't see this as a special box where a magic B plus comes. Now this is actually very close, as close as possible to the output stages or the driver stages of my amp. And this is by itself. Now this thing is required to make this work, I think. So so that's in the application. It is very important, because if you see this as a big voltage regulation circuitry, it still has some artifacts, and the LC is very competent in filtering the last artifacts out. And it is needed. So even though this uses a tube as a controlling mechanism, and it is far better than something like other voltage chip based like LM337 or 317. I forgot the other number that I've tried before, it had a 4-digit number. They have such a nasty impact on the sound, but with a tube in place and this extra stage, it is actually a proper application. So with that out of the way, and sort of now you have sort of a feeling where this falls in. So this was already in the application. Let's just shift that out of the way. Well, let's just leave it in, you can see it anyway. So what is happening with this voltage regulation? So this circuitry allows you with a pot to basically control the voltage that goes out here. And it has a bit of limitations. This is probably with this, if you go higher than this, you need to make some amendments in this circuitry, especially also with regards to filament supply, but we won't go into that. So you get to regulate the voltage quite easily, and it's relatively clean. And the way this works, rather than using multiple RC stages or LC stages to get the AC wave that you have after rectification, it is just a big bumpy road. And then rather than flattening, what we do is we apply one stage of flattening, so it's still a bit rough. Very choppy DC, if you will. And what we then do is, with a pass tube, it will cut off all the excess energy that it doesn't need. And so it does two things. One, it flattens out the signal, and two, you get to control what the voltage is, what it throws away. And the tube will dissipate all of that. So if you need more and you chop off a lot, you can actually also take two tubes, and that will have the effect that the impedance of this stage will get lower and lower. So that's the general idea. You know the application now. Let's get into the positives and negatives. So the positive of this is that you get to control the working points of your tubes, and that the working point is exactly the same all the time from start to finish. Another advantage is that with this in the signal path, this is the same a little bit as using a tube rectifier. Like people that use tube rectifiers have one big advantage, and that means that as the filament or the heater heats up, current only starts flowing around after like 9 to 12 seconds or 9 to 15 seconds, depending on how quickly it heats up. So you got a slow start of the high voltage circuitry. So you got that with this as well. So while your tubes here in your output stages are warming up, this is warming up, and it means that the current, the voltage here slowly comes up. So what I generally see is after about 6, 7, 8 seconds, the voltage starts creeping up, and then it takes another 8 seconds to really reach its maximum. And it's as this tube starts conducting, the power comes up. So that is advantage number 2. One is you get the control. 2 is you have a slow start of your high voltage. And then the number 3 advantage is that I find is that because it's sort of the quality of the power on your your 220 or your 120 or your 240, whatever voltage you get on the line. It matters a lot less with this type of circuitry, and maybe that's because there's still a bit of imprint from the circuitry itself. However, I just find that the quality, the line quality, just matters a lot less with this circuitry in place, and I still think it's a pretty high level thing. Mind you, you have to have a good filtering stage after this. So yes, you do away with the inductors. However, I still use one here. However, the demands placed on this inductor is not as great as if you would use it here. Because relatively what happens is you're talking about a near DC signal here. So it actually doesn't have to deal with much fluctuation in the signal. So generally you don't have to oversize this as much as you would in a normal power supply. You can be a bit laxer around. You can specify this much closer to the actual current that you need. So if your tube is taking 50 milliamps and you take a 50 milliamp specified unit inductor, it will function fine for you. So that's some of those are the positives. Now let's look at the limits. So what you have to realize is what people generally want with a power supply is a very low impedance power supply. Now when you make it active like this, it appears to be a low impedance circuitry if you measure it with some measuring standards. But of course we have a plate resistance here. Now this tube that I employ has 400 ohms. If you parallel, it's 200 ohms, so that's pretty good. However, probably not as good as some people who will really go all out on their inductors and they do just an LC network, a two-stage LC network to flatten the signal. However, this at 200 ohm is not too bad if you have two of them. I use one at the moment, 400 ohms. And what its limitation is its ability to instantly deliver current. Now, the nice thing about an LC stage at the end is that this becomes a current source by itself, so we're overcoming that partly. But I still find that if I have a single-ended amp and there's a huge fluctuation in power draw, that this is not a good, it is suboptimal. And so in my application of my amp, if you think back to part 2 in this series, I'm using a driver stage that is 9 milliamp, and then of course as the output stage I've got a differential amp which is near constant power draw. So that is where I think this circuitry shines, and not with a single-ended stage. I wouldn't use it. I'll probably go the old school way with a double LC configuration, and don't use this circuitry. I think that will deliver better results. So, and the other thing is, of course, this even after this circuitry, even with this cap flattening things out, this is still not usable. You still need to use something if you have a single-ended stage there. At least one RC filter after it. And that starts to become, for me, that's an acceptable level of sound quality it delivers. So that's the limits. However, as I said, when applied as I have applied it, this works well. You get the positives and very little of the negatives. Does it have an impact on the sound? Yes, it probably will have. I will do a comparison probably soon, with and without, and just to really sort of reacquaint myself with the difference. But it's at a pretty high level the way this is constructed, and with this tube. I've in the past also used the EL86, which has about 830 ohms plate resistance, and just used 2 of them. It's a pretty good solution. But if you have access to this tube, usually you can have this tube for cheap. It's very good for this application. It was designed for it. And as I said, if you parallel it, you really get to a low impedance, and it can react very quickly. So then finally, as the final part to this video, I hope now this starts to make sense to you. Some of the details. So let's just go into it. We've got our our AC here. Gets converted to whatever is appropriate for your circuitry. It depends on the voltages you need, your choosing of the output transformer. We rectify it. I tend to use Scotty diodes here. I take long life electrolytes. Just I tend to use Nichicon, but there are better options. This also this setup here means that this voltage will and the loading here will be a bit slower, will be controlled when this gets switched on. 2 times 220, so that's 110 effectively. That voltage is also so it's kind of flattened out, and then we use the tube here to for the grid. Sorry. So this choppy signal is taken to the pass tube. That is controlled by this NPN transistor. It uses that as a reference, and then it measures the voltage that is coming out, and it uses that with the potentiometer. You set how it corrects itself, and so this will keep the grid at such a voltage that the voltage is kept constant. It fluctuates a little bit in how much power draw this is, so it stabilizes out over time, but it will always fluctuate a little bit. Sorry, my screen goes off here. And then we use here one capacitor to flatten it out a little bit. And as I said, the last stage of this power supply is actually very close to where it's needed. So that is the rough functioning of this circuitry. As said, you can just buy this board. Actually, you can just buy this board online. However, I would always upgrade the components to long life and low ESR capacitors, and I would use better diodes than when you just standard buy this. And yeah, I really can recommend using very low plate resistance tube that generally works best. I think that is essential for getting the most out of this circuit. As I said, this is not perfect. Don't think this is perfect. I know that a lot of people that are designing single-ended amps, that they will actually use the tube somewhere here, so it will actually create a path to the ground, so by shunt, not by pass. And that's of course a very good approach. It's probably a better approach. However, as said, if you apply this one well within its limitations, this works well, and it probably avoids you having very large, especially I think for DIYs or people that want to set their working point. I think it has a lot of advantages, or your net quality is really low. It has a lot of advantages, this, and it's relatively compact. You get a bit of more power draw because you're putting a tube in it, but you're getting the slow starting return. So I think it's a nice mix of positives, and if you apply it well, this will serve you well, I think. Yeah, so that's it. I hope you found that useful and insightful. It's a crucial part of the whole amp design. As said, I quite appreciate the flexibility of this setup and its consistency. And that's it. Yeah. So thank you for watching. As said, I hope you got something out of it. This was part 3 of my design. In part 4 we'll probably look at the filament supply and tie off and just answer any questions that you may have. If you have any questions, please put them in the comments and I'll try to answer them, or I'll pick it up in the next video. Yes, thank you for watching, and have a brilliant day, and hope to catch you in the next video. Until then, bye bye, take care.